Welcome to Cruz Learning where it's just that easy with your favorite host, Professor Cruz. And today we're going to talk about solving systems of linear equations by substitution. So here we go. These are 4 steps that you could always use and they will always work to solve any problem by substitution. The first step is to solve for one variable. The second step is to substitute into the other equation, and I will explain to you what that means with example 1 in a second so it makes more sense. Step 3 is solve the equation, and finally step 4 is to evaluate the answer we get into an original equation to find the second variable. So when you look at these problems, you'll always have 2 variables, x and y, because you have 2 different equations, right? And because you have 2 different equations, you need 2 variables to be able to solve them. All right. So, or I should say that backwards, because you have 2 variables, you will need 2 equations in order for you to solve them. So here we go. The first step is to solve for one variable. If I look at the first equation, which is x plus y equals negative 15, is that problem solved for a variable? It is not, because the left side says x plus y. Remember, solve for means that the variable is by itself on that side of the equal sign. When I look at the second variable, it says that y equals 4x. Is this equation solved for any variable? Yes. It is solved for y because it says y equals. That's it. Y is by itself on that side of the equal sign. So step 1 does not need to be done. It's already done for you, which is great. Y equals 4x. Okay. So the second step, this is the substitution part, is to substitute the second equation into the first equation. So what we're going to do literally is I'm going to take this y and we're going to plug it into that y right there. Let me use blue, a different color, so that you can see what I'm going to do. I'm going to take whatever y is and I'm going to plug it in there. Well, what's y? Y is 4x. So I'm going to write down x plus, but instead of writing that y, I'm going to open a parentheses. I'm going to write down what y equals. That's the substitution part. Y equals 4x. So I'm going to write down 4x, close my parentheses, equals negative 15. Now this right here, it's perfect because it's one equation in one variable that I can easily solve. X plus 4x is 5x. So I'm going to combine like terms, and this equals negative 15. And x is not by itself because it's being multiplied by 5. So I'm going to use my inverse operation and divide by 5. And that's going to give me that x equals negative 3. So x equals negative 3. Perfect. I found x. X is negative 3. Now, how do I find y? Well, I solved the equation. That was step number 3. Okay. So step number 4 is to evaluate the answer into the original equation, just like we did with elimination. So what I'm going to do is that I want to find y. I want to be smart about this. I already have one equation that is solved for y, and that equation is equation number 2. Equation number 2 is already solved for y. So all I have to do is plug in x. Y equals 4, but instead of writing x, I open parentheses, and I write down what x equals, which is negative 3, and that definitely equals 4 times negative 3, which is negative 12. So my answer is negative 12. I hope that makes sense. Negative 3 comma negative 12. All right, so let's do it one more time, because when we do more problems, hopefully those 4 steps will become visible. Okay, step number 1, solve one equation for one variable, right? Now the thing is, both equations are solved for one variable, the same variable, which in this case is y. Well, this is perfect, because if they're both solved for y, all you have to do is set one equal to the other, right? Because when I plug in y into the other, I have to plug in what y equals that. So then what I'm going to do is I'm going to rewrite. Instead of writing y, I'm going to write down negative 2 over 5x plus 2. And that equals 10 over 3x minus 54. Now, when I get to this problem, you can see I have 2 different fractions. You can tackle this 2 different ways. You can find the greatest I should say the least common multiple, and multiply every single term by the least common multiple, or multiply by each denominator individually. Now, I noticed that because 5 and 3, 5 times 3, it's 15, and the least common multiple between 5 and 3 is 15, because 3, 6, 9, 12, 15. Hopefully you remember this. And then 5, 10, 15. The first one that repeats is 15. Okay, so I'm going to multiply every single term in this equation by 15. Now, don't be scared. You could use your calculator if you want to. All right, so here we go. Every single term multiplied by 15. When I multiply the first term by 15, which is negative 2 over 5. I'm going to do this on the side, actually. Okay, so negative 2 over 5 times 15. Remember that I can multiply anything I want times a fraction. As long as I do one thing, put it over 1. Okay, and you can multiply top by top and then divide, or you could simplify first. It's up to you, right? So I'm going to simplify first because I like to work with smaller numbers. So 15 simplifies with 5. That will be 1 and 3, right? Because 15 divided by 5 is 3, and 5 divided by 5 is 1. And then negative 2 times 3 is just negative 6, over 1 times 1 is 1. So this is negative 6. Another way of thinking about it, okay, and this might be an easier way actually to think about it if you didn't understand what I just did. And this is the only time that I'm going to do it, so please pay close attention, is just multiply top by top, bottom by bottom. So the numerators, 2 times 15 gives you 30, that's TBT, over BBB, which is bottom by bottom. 5 times 1 is 5, okay? And then you divide, and this simplifies. Negative 30 divided by 5, negative 6. So either way, you could do whichever it works for you best, okay? So this is negative 6x plus 2 times 15 is 30. So remember, I'm multiplying everything times 15, and this equals 15 times 100, it's 150, and that divided by 3, let's see, it's 50, right? Hopefully that makes sense. Another way of doing it is 15 divided by 3, right? That will be 3, that will be 5, and then 5 times 10 is 50. You could always divide by the denominator first, then multiply by the numerator, and that will be x. And then I'm going to use my calculator real quick. 54 times 15, because that's a big number, that's 810, so minus 810. So what I did is that I multiplied every single term by 15. That way I was able to cancel all the fractions, and now I don't have any fractions. So I can move all the variables to one side and all the constants to the other. So I'm going to move all the variables to the left. So I'm going to subtract 50x from both sides. And I'm going to move all the constants to the right. So I'm going to subtract 30 from both sides. Okay, I want to cancel those. And as an answer then to this, I'm going to get that negative, right? So negative 56x, these cancel, equals 50 minus 50 cancels, and I get negative, so you have negative 180 minus 30, which is same sign, add and keep, so sorry, that will be 800, negative 840. Okay, and then I'm going to take that negative 840, and I'm going to divide it by negative 56. Okay, so I'm going to take both sides, and I'm going to divide by negative 56. What I'm doing on one side, I'm doing on the other. This will cancel, and it will give me that x equals positive 15. So I just found x. X is 15. Now we have to find y, but hopefully you know that finding y is not that bad. All you have to do is plug it back into any of the equations. Both of the equations have fractions, but it looks like this might be the easiest one to use, right? That might be the easiest one to use. So then I'm going to write down y equals negative 2/5, open a parentheses, plus 2. And wherever I see the parentheses, I'm going to plug in that 15. And I'm going to divide first, then multiply, so I work with smaller numbers. 15 divided by 5 is 3. right? 15 divided by 5 is 3. Multiply times negative 2 is going to give me negative 6 plus 2. And negative 6 plus 2 is just negative 4. So my answer here for problem number 3 will be 15, comma, negative 4. That will be the answer for this problem. I hope that that makes sense. All right, so let's keep moving because there's different type of problems. Okay, how about this one? Number 5, solve the system equations by substitution. So now you have an equation that is solved for one variable and the other one is not. But that's perfect because one of them is solved for the variable. So the first step was already done for you. All we have to do is plug in y, whatever y equals, into the other. But, well, let's do it. Let's do it. I have 2x minus 4. I'm going to open a parentheses. I'm going to write whatever that is. That's 1/2 x plus 7 over 4. That close the parentheses equals 1. So I rewrote the second equation, but instead of writing y, I wrote what y equals. That's the substitution part. Now I'm going to do what I learned how to do when I was simplifying using order of operations. So 2x, and then I'm going to distribute a negative 4. So negative 4 times 1/2 is just the same thing as finding half of something. Okay, or divide by the denominator, you get 2. Multiply by the numerator, still 2, so negative 2x. Negative times a positive is a negative. And when I multiply a fraction times 4, the 4's will cancel. 4 divided by 4 is 1, times 7 is just 7, and that equals 1. All right, now look at what happens. The x's cancel. If I combine like terms 2x minus 2x, it cancels, it gives you 0, and you get the statement negative 7 equals 1. Or if you were to add 7, then you'll get that if you add 7 on both sides, you can stop there, right? And you can stop here because there's no longer variables, and you can see that this is not true. That's not a true statement. And I can keep going, though, if I decide to move the 7 before the x's, and I'm going to get that 0 equals 8, which is also not true. I'm getting false statements. That means that the answer does not exist. There's no solution, right? There's no solution. So you're going to enter D and E for both of them according to my instructions, okay? Now, if this was a true statement like before, that we saw that we did 0 equals 0, then you will use the double zeros, or 10 equals 10. You will use the double zeros, which means infinitely many solutions when you get a true statement. So these are not true statements. If you get negative 10 equals negative 10, that's a true statement. If you get 5 equals 5, that's a true statement. If you get 0 equals 0, that's a true statement. And you will enter this right here. But if not, D and E, no solution does not exist. Great job. Try number 6. I am not going to do it. But if you would like to pause the video and copy this problem right real quick, you should get infinitely many solutions. That is the answer for number 6. All right, perfect. We have 2 more questions and then we're done. Number 7. One number is 1 less than a second number. Oh my goodness. Twice the second number is 25 less than 5 times the first. Find the 2 numbers. Every time that I read this, it's like a riddle, okay? So I'm going to teach you right here, right now, live, how to solve a riddle, a math riddle like this. Basically, you have to translate English to algebraic expressions, do it sentence by sentence, and do it in order. So you have that one number is less than a second number. We're going to be talking about 2 different numbers here. So we're going to call the first number x. So this is the first number. Make sure that you define every variable. Y, I'm going to call it a second number. Okay, so x is my first number. Y is going to be my second number. Now, I'm going to reread the first equation, the first sentence, so I can write an equation exactly how I'm reading it. One number is, well, this is the first number. My first number is x, so I'm going to write down x, and this means equal sign. So is the equal sign. So x equals. See how I'm doing it in order? Okay. So x, it says that is one less than a second number. Now, hopefully, if you took developmental math or if you took algebra back in high school, you learned that every time that you read the word less than or the words less than, you need to flip whatever you see. What's before the less than comes after, and what it's after comes before. So I'm not going to write 1 minus y, that it's completely wrong. I'm going to write y minus 1. It is very, very important that you understand that when you see less than or more than, you have to flip the two things that you're talking about. You cannot write 1 minus y. 1 minus y is wrong. You have to write y minus 1. All right, perfect. So I have my first equation, my first sentence. Now let's read the second sentence for the second equation. Twice the second number. So that means take the second number and multiply times 2. So again, whatever I see, I write twice the second number, that means 2y, is, there's my is again, so that's my equal sign, is 25 less than 5 times the first. So the less than business again means that I'm going to flip whatever I see before and after. So after I see 5 times the first number. So that is 5x minus, because it's less than, 25. Okay, so those are my two equations. I just wrote a system of equations, and I'm going to use substitution. Easiest thing to do here is to use substitution because the x is very easy to solve for. Okay, so what I'm going to do is I'm going to plug in wherever I see the x. I'm not going to write x. I'm going to write down what x equals. Okay, so I'm going to write 2y equals 5, open parentheses, y minus 1, close parentheses, minus 25. From here, it shouldn't be that mad. This is just regular algebra, pre-algebra actually. This is 5y minus 5. And then you bring down the minus 25. That was distributive property. And now I'm going to move all the y's to the left. Okay, so I'm going to continue it on the side over here because I have to do that last problem, number 8, I believe. So here we go. So if I subtract 5y from both sides, I'm going to get negative 3y on the left. And if I combine the negative 5 and the negative 25 on the right, I'm going to get negative 30. Okay. And then the last step here will be to divide by negative 3 on both sides. And I will get y equals positive 10. So that's the answer for y, the second number. So the larger number is 10, okay? That's the second number. And I said that was the larger number. Well, yes, it is. Because how do I find x? Well, they told me with the first sentence that one number is 1 less than the second number. So I just find y. All I have to do is go back to the original equation that I wrote and plug it back in, right? So hopefully you can see, and I'm going to erase it and substitute, that if I substitute y with 10, x equals 10 minus 1. And 10 minus 1 is going to be 9. So that will be my answer. The smaller number is 9 and the larger number is 10. That's how you do that problem. And the last problem, which is a word problem, probably not your favorite. It might be your favorite, who knows? All right, so here we go. In 1 year, Michael earned $6,300 as a work study in college. He invested part of the money at 9% and the rest at 7%. If he received a total of $493 in interest in the second year, at the end of the year, how much was invested at 7% and how much was invested at 9%? So this looks kind of weird. So we're going to apply what we know what to do. Okay, this is a system of equations. You have a thing 1 and you have a thing 2. Hopefully you learned that in the previous lesson from 2.3. So, and you have totals. Okay, so here we go. My totals here are 6,300 and they say a total of 493. So I could write down two equations. The totals tell me what to write the equation for. So the first equation is going to be for how much Michael earned working. Okay, well, I don't know. I just know that there's two parts to it, right? So I could rewrite this as x plus y equals 6,300. XY is one part of what he earned. X is one part, Y is the other part. Okay. Now he invested part of the money at 9%. I don't know which part is which, so I could pick whichever variable I want. So I'm going to say 0.09, which is 9% of X of one part. Okay. And the rest, so whatever it was not with X, it went with Y, was a 7%. So 0.07 Y equals the amount that he earned in the interest, 493. So notice that the first equation is for the total amount he earned, and the second equation is all about the interest. Okay, so I wrote two different equations for two different totals. Okay, perfect. So now what can I do if I'm going to use substitution? Well, the first thing is I don't want those decimals there, and I could cancel all the decimals if I just multiply everything by 100. The reason is because I have to move the decimal point twice, and 100 has two zeros. So if I multiply everything in this by 100, just like we did when we were doing elimination, I'm going to get, well, the first one, 0.09 times 100 is just 9x plus 0.07 times 100 is just 7y equals, and I'll just add two zeros at the end. So that's 49,300. So there we go. Now, these are big numbers, right? You might be saying, what the heck is going on? But don't worry, because this is by substitution. So all we have to do now is solve for one variable. Okay, so here we have to solve because none of the equations are solved for one variable. So it's up to you. You could solve for x or you could solve for y. It doesn't really matter. At this point, I'm just going to choose x. Okay, I'm going to choose x and I'm going to solve for x. So in order to solve for x, I'm going to have to move that y to the other side, correct? So I'm going to rewrite this equation. So this is equation 2 rewritten. And that will be x equals 6,300 minus y. So I rewrote equation 2 into this. And now I can substitute equation 1. Okay. Equation 2 into equation 1. That's for x, not for y, but for x. So wherever you see the x, I'm going to take whatever x equals, and I'm going to plug it in. So here we go. I'm going to do y, open parentheses, okay? And that will be 63, let me use color coding, 6,300 plus, okay, and I'm going to do plus, hold on a second, because I forgot something very, very important. I forgot the minus y part. So it's very important that you put the variable, all right? Plus 7y equals 49,300. Okay, now from here, again, I'm going to use my handy dandy calculator and multiply because I have to distribute 9. So 9 times 6,300, 9 times 63 is just 567. Add the two zeros at the end. Okay, add the two zeros at the end. Minus 9y plus 7y equals 49,300. Okay, and now I'm going to combine like terms. So these are like terms. So that will combine into negative 2y. And that equals the same, right? I have not done anything on the right side or anything with the 56,700. And then 2y is not by itself because it's being subtracted by 56 or added, sorry, by 56. So I'm going to have to subtract 56,700 from both sides. 56,700. Okay, so that's exactly what I'm going to do in my calculator right now. 49,300 minus 56,700. And that equals negative 2y equals negative 7,400. And the last step will be to divide this by 2, well, by negative 2, so I could get y by itself. And when I get that, it's going to give me that y equals 3,700. So I found out what y is. Y equals 3,700. If I find out y, how can I find x? Very simple. I'm going to plug it in one of the original equations. It looks like this is the easiest one to plug in. But note, it's the same thing as that. So all I have to do is subtract that from 6,300, and it's going to give me the answer for x. So x equals 2,600. Okay, so that's how you do that problem, and that's how you do 2.4. This was Professor Cruz with eCruz Learning, and it's just that easy.